Um, okay, so how do I get this? So let's pretend that you're this responsible person and you're preparing to go out and grab coffee before your first Zoom meeting, but you need to grab some of your work clothes and your business pants, and they're not in the room with you. And so you walk to their location with the goal of getting your green sweats. And as you pass the living room, you catch a glimpse of your messy couch. And despite having the goal of retrieving your sweats and not dealing with this whole couch headache, your attention is nevertheless automatically guided towards items that match your working memory representation. They seem to almost pop out from the rest of the world. And since it's unlikely that you might want to go outside with just your pants on, you might want to grab a full ensemble, it's reasonable to wonder whether attention is influenced and guided by all of the features that are actively maintained or only one of them. And so just to summarize, previous research has shown robust attentional guidance when a single working memory feature is maintained. But whether two actively maintained working memory items guide attention is less clear and less consistently replicated. The literature suggests that there are two alternatives. So either both items are capable of guiding attention equally, or only one of these items is capable of doing so. And so in our first task I'm going to talk about today, we're going to try and tease these apart and determine which alternative the data is more likely to reject. So participants are shown two colors and are asked to remember them over a short delay for a memory test that happens at the end of each trial. Participants are randomly probed on one of the items, and they're just told to report them as precisely as possible on the color wheel. And prior to having their memory probed, they perform a search task where color is irrelevant. And here the search display just flashes briefly, and participants need to report the orientation of a target line. So here it's in the top, and it's tilted to the left. And so first, if we just look at memory, I'm on the y-axis, I'm showing memory strength D prime, which is from the TCC model, which is relatively new. And so to summarize this model quickly, it estimates the precision of memory representations and is built on the framework of signal detection theory and incorporates the perceptual scaling and the psychological non-uniformity of distance and color space. And so just shortly, it's a simple and sensitive model which accurately estimates the precision of memory using a single parameter D prime. And if you're interested in more, Tim gave a great TCC talk on NeuroMatch, and you can read more on this easy to digest primer on our lab website. And so if we look at the search task performance, we can look at response time on the y-axis. If these online representations are guiding attention, we'd expect participants to be faster when the target is encircled in one of those memory colors compared to a distractor. And that's what we find. And so instead of showing two bars, I'm just going to take the difference and show a search effect. And here, just like D prime, higher is better. It shows stronger influence of the memory items. And so while this shows that attentional guidance occurs when multiple items are maintained, it doesn't determine whether one or both items are able to guide attention. And so one condition that I hadn't mentioned before is that at the end of some trials, we allowed participants to choose which memory item they'd like to report. And previous work has shown that when people are free to choose, that on average, they choose the most well-represented item. And for us, we didn't tell them to do that. We just told them to pick any item that they chose. We still expected that people have this internal representation of which item is better represented and would probably pick that. So forced report is going to give us an estimate of the average memory strength, while free report might give us an estimate of any asymmetries in memory strength, like if one item is being maintained better than the other or not. And so here I've just expanded this same figure as before. And we can see when we look at free report that the memory strength is overall higher than forced report, which suggests that participants chose an item that was on average better represented, and that one of these items is represented with much lower representational fidelity, much lower precision. And if we look at the search effect for these trials, if this well-represented item is responsible for driving the guidance effect, then we'd expect a search effect when the chosen item was present in the search display. But when that item was absent, so we're probing the search effect for a secondary, less well-represented item, we should expect a much smaller search effect. And that's exactly what we find. And so just to quickly summarize this first experiment, these results demonstrate that natural within-trial variation in the representational fidelity between items occurs. We didn't make any efforts to control how people maintained these items, and that this variation can explain which item underlies the search effect on a given trial and suggests that one well-represented item guides attention despite how many are maintained. And while we think that this might just be related to natural variation in the way that the memory system works, it is consistent with multiple explanations. So one explanation in the literature is the focus of attention account, and the other is the natural variation account that I'm describing today. So just to talk about the focus of attention account really quickly, this one, is, at least in respect to multiple item guidance, is built on the idea that working memory is fundamentally stratified and that the focus attention is narrow and can maintain a single item. So that green item over there on the right is maintained within the focus of attention and has an elevated status compared to other items. And this special status, according to this model, uniquely privileges one item to influence behavior while all others are incapable of doing so. And so a narrow focus of attention intuitively explains the single item guidance effect. We know that people can maintain multiple items, but if they're only getting guidance from one, it seems reasonable to assume that it's probably because the focus of attention exists and can only hold one item. But we think perhaps a more straightforward or parsimonious description of the multiple item effect has to do more with natural variation in memory strength and independent noise on multiply maintained items. And so it's relatively well accepted that working memory items intrinsically vary in how accurately they reflect the encoded item. And we know that the memory system maintains representations as noisy facsimiles of the truth. And from this, it seems reasonable to assume that a poorly represented item simply couldn't effectively guide attention. And again, for us, the single item guidance would be predicted by independent noise being accumulated over items, such that one of these items is going to be best represented. And if I can just quickly show an example of how we're thinking about this. On the right, let's say that we just have one item to be encoded. And on the left, I'm showing color channels on the x-axis and familiarity. You can think about these as neuronal populations that respond to these colors. And when you see the target in the middle, you get this large familiarity signal, a lot of activity from these particular populations. And when the display disappears, noise is going to be added to that representation. But because you can attend to only one item or you have enough resources to protect it, the noise isn't going to overcome the representation. And on most trials, you should get guidance. But when you try to encode two items equally well, you're going to do so with less precision. And when random noise is added, we suppose that on average, you could get one good and one bad representation. And there's no way to guide from a noisy channel that isn't well represented, like on the right. And we predict that you'd see guidance on average for one item, the best represented item. So the focus of attention account neatly explains these results. And we believe that the natural variation account can do so as well. And so we want to see maybe what the focus of attention account might be adding in addition. So if these effects can be explained without needing to invoke the focus of attention, we ask really, what is it getting us? We know that simply existing within the focus of attention can't be enough. It's reasonable to assume that an item must be an accurate representation of the encoded item to get guidance. So like you could imagine that if you're remembering purple instead of green, there'd be no way to get guidance towards green because it's not an accurate representation of that color. And so to explore what the focus of attention might be adding in addition, we experimentally manipulate which items are in the focus of attention using a retro cue. So in the next task, we introduce a retro cue, the neutral cue that tells participants we're going to test you on either one of these items, so remember them equally, and the directional cue, which tells them with 100% certainty that we're going to test on this item at the end of the task. And so previously, it's been incredibly difficult to separate memory strength and the focus of attention because an item that's focally attended is provided more resources and is often better represented than any other item. So to try and manipulate memory strength within the focus of attention, we introduced a noise manipulation. So on the left, we add these perceptual noise dots to introduce confusability in the target color, and we limit the encoding time helpfully to further inhibit or harm these memories. And in the low precision noise trials, we expect participants to have still strong memories for these. It's very little perturbation to their memory. And so the task is overall the same. We introduce the noise at the top, and then we introduce the retro cue, but the task remains the same other than that. And so I'll jump into the results. And so here we're just looking at the direct cue trials, and we see that the noise manipulation successfully modulated memory strength. So the high noise item is maintained with less representational fidelity with a lower D prime than the high noise item. And the search effect tracks memory really nicely. So we see that maintaining a high noise item, even within the focus of attention, manipulates how these items are able to interact with the environment. And while it's not necessarily novel to say that the focus of attention can maintain noisy items, it hasn't really been shown in this way in the past that we can modulate the memory strength and the focus of attention and show how that directly influences multiple item guidance. And when we look at the neutral trials, we see again that the search effect tracks really nicely with the memory strength across all conditions. And so the retro queue appeared to have a substantial effect on memory strength. The direct queue memories in the green bars are much higher than the neutral queue memory strength in the purple bars. But the search effect tracks memory and begs the question, what else might the focus of attention be adding other than facilitating better memories? So we wanted to look at the relationship between memory strength and search in general. And I have memory strength on the x-axis now and the search effect on the y-axis. And what we find is this really nice, clear relationship between memory strength and search across all of the experiments in the preprint. And so I didn't talk about some of these experiments, but I'm just showing that memory strength is really nicely correlated with the search effect within and across experiments. And if we focus our attention at the intercept, we see almost zero guidance of a d prime of 2, which suggests that working memory representations must be very well represented before they can influence attention. And if the requisite memory strength is at least a d prime of 2, then it's reasonable to assume that on average, 2 items wouldn't be maintained with that sort of precision. Maybe one of them would and one wouldn't. And so in summary, a single well-represented item guides attention when 2 colors are actively maintained in the first experiment. And memory strength can predict the search effect. And it seems that the focus of attention facilitates memory, but doesn't add anything or change the relationship between them. And so we propose that natural variation between multiple working memory items can explain these effects without any extra assumptions about the structure of working memory, and that across all experiments, memory strength nicely predicts the search effect. And so for me, this plot really drives home the point that we're not really sure why we might need to invoke the focus of attention here if memory strength must be accounted for. Only well-represented items can guide. We know that memory strength intrinsically varies between online items, and it can do the bulk of the explanatory work. Greater memory strength equals a greater search effect. And while I am not against the idea of the focus of attention, it's a really intuitive idea in this account. We just say that we don't really find any evidence to support that it's adding anything to the discussion or to the explanatory work. Thanks.
Great talk. Thank you so much. So because we started you a bit late, we'll give you a few extra minutes for question time here. Lots of questions coming through. Try to sort through which ones are for you and which ones are for the others. Okay, so Keisuke Fukuda asks, Jamal, interesting talk. Why is baseline search effect the same as the search effect for the item that was reported in the free report condition?
Yeah, I think that's a really good question and something that I've thought a lot about. I think that the one explanation is potentially that because participants see the item in the search task before they need to pick, if you're maybe had a lapse where you have low representational fidelity of 2 items, getting that opportunity to re-encode is going to give that item better representational fidelity and encourage people to encode that item, even though they didn't get searched before. And so this is like averaged over hundreds of trials. And so I think that that's probably the explanation here, but I think it's a great question. And if I could more tightly control which item was actually better represented, we might see stronger guidance.
Thank you. So what you're saying, just to reiterate, is that the search itself can impact the subsequent memory report.
Yeah, definitely. And so I didn't show it here, but getting that opportunity to re-encode does facilitate memory strength. You see about an 8% boost in the D prime across the conditions.
Okay, thank you.
Sure.
Sage Butcher asks, cool talk, Jamal. Did in experiment 1, subjects choose the item that was present in the search display more often?
Yeah, that's a great question. And that was something we were really worried about at the outset. But on average, they didn't. They choose it about 60% of the time, which isn't really that much more than we expected. I can say that some people maybe didn't read the instructions or didn't understand and picked it all the time, and they were removed from any analysis. So if they always picked that item that